Imagine a moment in science so unsettling that it doesn't answer questions, it erases them. A moment when astronomers stop debating, stop theorizing, and simply sit in silence, staring at the data on their screens. Because what they're seeing should not exist. This is one of those moments. And it comes from the James Webb Space Telescope. Webb was built to look farther back in time than any instrument in human history. Far enough to witness the universe's earliest years, a time when the first weak sparks of light were just beginning to form. Scientists expected to see chaos. Dim, fragile clouds of gas. Half-formed galaxies still struggling to hold themselves together. Structures in their infancy, barely learning how to exist. That was the plan. But that is not what Webb found. Instead, it revealed objects that looked disturbingly mature. Bright. Compact. Massive. Ordered. These were not fragile beginnings. These were systems that looked like they had already lived long, complex lives, at a time when the universe itself was barely out of childhood. At first, researchers assumed something had gone wrong. Maybe the brightness was misleading. Maybe these objects were much closer than they appeared. Maybe the distances were miscalculated. Hope lingered, briefly. Then spectroscopy confirmed the truth. The redshifts were real. The distances were real. These objects existed when the universe was only a few 100 million years old. And yet, they did not behave like newborn galaxies. They showed structure. Density. Immense stellar populations. Signs of rapid evolution that should have taken billions of years, time the early universe simply did not have. One strange object became two. Two became dozens. Then entire populations appeared across Webb's deepest images. The shock wasn't that something unusual existed. The shock was how common these objects seemed to be. According to the standard cosmological model, galaxies grow slowly. Gas collapses under gravity. Stars ignite. Energy feedback limits growth. Only a fraction of available material ever turns into stars. This framework has worked remarkably well for decades. But Webb is now seeing objects where nearly all available gas appears to have been converted into stars, not gradually, not inefficiently, but almost completely. That level of efficiency isn't just rare. According to current theory, it shouldn't be possible at all. These objects don't match known galaxies. They don't resemble quasars. They don't behave like star clusters or protogalaxies. Their properties sit outside the boundaries of established theory. And that's when the conversation took a darker turn. What if these objects aren't galaxies? What if they belong to an entirely new category of cosmic structure, one we've never seen before because we've never been able to look this far back in time? As Webb continues to peer deeper into the cosmos, the picture grows even more unsettling. Some of these objects appear at distances where, based on our understanding of cosmic expansion, their light should not have reached us yet. They exist beyond what should be a visible boundary, receding faster than light due to the expansion of space itself. And yet, they are there. This doesn't directly violate relativity. Space itself can expand faster than light, but the number, brightness, and maturity of these objects are pushing that explanation to its limits. The early universe is starting to look uncomfortably old. If massive, organized structures already existed this early, then the universe did not begin as a simple, featureless environment waiting for complexity to emerge. It suggests something far more radical. It suggests that large-scale structure may have existed before the era we've always called the beginning. Some physicists are now revisiting ideas once dismissed as fringe. Ideas suggesting the Big Bang may not have been the birth of everything, but a transition, a phase change, a moment when an already existing universe entered a new state. If that's true, then James Webb may not be showing us the first galaxies at all. It may be revealing leftovers from a much older cosmic history, fossil structures from a time before the universe became transparent to light. This possibility cuts straight into the foundation of modern cosmology. The standard model depends on a clear beginning, a hot, dense origin followed by gradual structure formation. But when observations refuse to fit that timeline, the problem isn't minor. It's existential. Either our understanding of galaxy formation is deeply incomplete, or the universe itself is far older, stranger, and more complex than we have allowed ourselves to imagine. And that is why these discoveries feel so unsettling. James Webb isn't just adding new details to an old story. It's challenging the story itself. The timing doesn't align. The growth rates don't make sense. The distribution of matter behaves in ways we didn't predict. When contradictions pile up, scientists are forced to confront an uncomfortable truth. The framework holding everything together may need to be rebuilt. James Webb has not destroyed physics. But it has revealed cracks deep enough that ignoring them is no longer an option.